Welcome students to Pradeep Sir classes as BSc where logo can talk the physics, and we are in IIT Foundation course ICSE-10 and work energy power, and it is all about numericals and chapter number 2 lecture number 6. So students, you can check the description box for the previous one, that is from 1 to 5 number lecture on that particular chapter. And obviously since this is a numerical one, so you have first of all write down the numericals and then try again and then come back for the particular answer. Okay, so let's start with the next one, that is it will be, I think, question number 11. So question number 11, and a man raises a box of 50 kg to a height of 2 meter in 2 minutes. So this is the ground level, and a boy can raises a box of 50 kg. So there is a box of 50 kg. 50 kg. This is the mass of this one, and it raises a box of 50 kg to a height of 2 meter. To a height of 2 meter. So this is, I think, you have to take as this is the height of that particular one, which is 2 meter. So this is 2 meter, and this is h. Okay, so this is h, and the value of g is you have to take any one of them. So g you can take as 10 meter by second square or 9.8 meter per second. Okay, so students, you have to calculate the work done, and that is work equal to mgh. Work equal to mgh. So in place of m you can write 50, and in place of g and h. So this is 50 into g means 10 into h 2. So these joule. This is the work done. Work equal to mgh or F into s, that the force act in the downward direction, and you have to lift or raises it up to height 2 meter. So raises the same box, and while another man raises the same box to the same height in 5 minutes, but it takes first boy takes 2 minutes, and another one raises this one, and the work done, so work does is same, this amount of work done, so work done is same, and this is W1, but here W2 is equal to W1. Okay, and the time is here 5 minutes. 5 minutes. Okay, so compare the work done. So you can compare easily. W1 is to W2 equal to 1 is to 1, since the work done is same for the height is same, so the work done is also same for that particular one. So the ratio of the work done is 1 is to 1. But the power developed by them, what is the power of this one? So power equal to, we do that power equal to work done by time, and here it is a minute, and you can convert it into second. So you have to multiply 60, and again P2 equal to work done 2 by 5 into 60, since it is 5 minutes. Okay, so this is the power, this and this one, and you can take as P1 is to P2. So you have to compare this one. So work done by 2 into 60 is to the work done by the 2, so W2 by 5 into 60. 5 into 60, but W1 2 is equal to 1, so this and this cancel, this one, and 60 also cancel. So here it is half, and here it is 2, and you can multiply with P1 is to P2. This is equal to, you have to multiply it with 10. So when multiply this one with 10, then 2 5s are 10, so it is 5, and this is equal to 5 2s are 10, so this is 2. So 5 is to 2. This is the power, ratio of the power. You have to compare the power of the man 1 and 2. So this is man 1 and man 2. Since their work done, the height is same and the weight is same, so the work done is same, but the power is different, because power is the reciprocal of time. How fast the particular man can do that particular work. So this is the power. So it is 1 by 2 is to 1 by 5. When students, you have seen that the work done is same, but the time is different, then just take the reciprocal, ratio of the reciprocal. So if it is this into this, then you can easily say that the ratio of the power is T2 is to T1. Okay, so the ratio of the reciprocal, take a reciprocal of the time, and then easily you have to cross multiply this and this one, and you can get the reciprocal of the time. That is, you can easily get the power consumed by that particular man. Okay, so for the next one, go for the next numerical, that is question number 12. Question number 12, and it is so 12, write down the question first and you can try. And I think if it's it is a problematic function, that is you have to calculate the last one. See, there is efficiency is given. Okay, so a pump is used to lift a 500 kg of water. So 500 kg of water, there is mass is given 500 kg, and from a depth of, so the height is also given, there is 80 meters, and time is also given, there is 10 seconds. The first number problem is you have to calculate the work done by the pump. So work done by the pump. So work done by the pump, and this is equal to mgh, and here G is given or not? Yes, it is 10. So M equal to 500, and then G, this is 10, and H is 80. So 5, 8 is a 40, then 40, and again 2, 1, and this one. So 1, 2, 3, 4, and 40, then this one. So 4 into 10 to the power of 5. So 4 into 10 to the power of 5 joule. So work done is work done by the pump, and the power at which the pump works. So power equal to students work done by time, and the work done is 4 into 10 to the power of 5 by time is given. So time is 10. So you can write 4 into 10 to the power of 4 watt. 4 into 10 to the power. So 0 and 0 cancel this one, and you can also convert this one, and so then this will be 4 into 10 to the power of 4, or you can write as 40 into 10 to the power of 3, or 40 kilowatt. 40 kilowatt. Okay. So the power at which the pump works, and the last one is the power rating of the pump if its efficiency is given. So efficiency is given, and students, you have to know about the efficiency and the power rating. What is the difference between the efficiency and power rating of a pump? So efficiency means efficiency equal to useful power by input, by power input. So power input, what is the input of the power within particular pump, and this is called power input, is called power rating. So power rating, that is power input, power input. then this is equal to useful power by efficiency. So the power is 40, that is 4 into 10 to the power 4. 4 into 10 to the power of 4 watt, and the efficiency is 40%. So if you give 100 kilowatt, then it can consume or useful power is 40, that is 40%. So 40 by 100, so 40 by 100, so 4 and this cancel this one, so 40 when cancel this one, then it remain 10 to the power of 3 here, and this cancel, and then 100, so 100 into 10 to the power 3, and 10 to the power of 3 means, students, kilowatt, so this is 100 kilowatt. So 100 kilowatt is the power rating of the pump. So 100 kilowatt is the power rating. Okay. So the next one is, an ox can apply a maximum force of 1000 Newton and it is taking part in a cart race and is able to pull the cart at a constant speed. So last 13 and 14 numericals is based on the relations with power and the force and velocity. Okay, so students, first of all you have know that particular one, and I can also derive the formula. There is work done by time and work equal to force into displacement. Since it is a scalar function, so this is by time, and force dot displacement by time, there is velocity. So power equal to F dot V, or if the theta is 0, that is the velocity is along the direction of force. If I apply the force and the velocity, change in velocity, and the change in velocity takes place along the direction of force, then you can take as the multiplication, simply multiplication of this one. It is not a cross product, it is dot product. Like that, it is just used as multiplication, as a multiplication sign. So power, what is the unit of power? What is the unit of force? What is the unit of velocity? Meter per second, Newton, watt, and the equation is P equal to F into V. And the question number 13. So question number 13 is, an ox can apply maximum force. There is force is given and this is 1000 Newton, and it is taking part in a cart race and is able to pull the cart with a speed of 30 meters. So V is also given 30 meters per second, and calculate the power developed by the ox. So power equal to F into V. So you have to just multiply 30, then 1, 2, 3, or you can write as 30 kilowatt. And I think students, you are able to understand. It is a easy numericals one, and I can prove also that particular equations in the previous class. So go back to the lecture number 5 and easily can understand the particular equation. The next one is, if the power of a motor is 40 kilowatt. So question number 14, if the power of the motor is given, so power equal to 40 kilowatt, and what speed can it raise a load of this one? So speed equal to question mark. You have to calculate the speed, and force is given. Force is equal to 20,000 Newton. So 20,000 Newton, and students, the equation is power equal to FV. So power equal to FV. Then you have to calculate V. So power by force, and the power is 40 into 10 to the power of 3. and this is 20 into 10 to the power of 3. Okay, 20 into 10 to the 3. So 3 cancel this one, and this is 2. So 2 meter per second. 2 meter per second. And the section part question exercise, that is 2A. The numericals portion is completed, and for the next day I start with this book, Concise Physics. There is different forms of energy. Okay. So for the next lecture, I discuss with different forms of energy. There is mainly a mechanical energy. Then when mechanical energy is completed, then it starts with a different chemical energy, solar energy, heat energy, magnetic, and the different forms of energy, and all the related energy related concepts. So for the next lecture number, that will be lecture number 7. Okay, so for that particulars I discuss with mechanical energy, that is kinetic energy as well as potential energy. Okay, and students, if you like that particular channel, Producer Classes as PS, again I say, then obviously you subscribe, like and share with your friends, and last of all press the bell notification button so that you can easily take the notification of that particular class as I upload it. Okay, so thank you, and last of all, continue your study. Okay, bye.